Hi, everyone. Welcome to another week. If you've been following along, we've been doing a few of these, and we finally decided to formalize it. These weekly chats between Laura and I, where we discuss things about Bytewax or different streaming concepts. So you're now listening to or watching the inaugural, because it actually has a name now, Byte Talk. So these are our Byte Talks. And welcome. Hey, Laura, how are you doing?
Welcome. Hey, Zander. It's really great to be here. And I'm very excited that we're now introducing this series as Byte Talks, where we talk all things streaming.
All
That should
things
be our
bytes,
slogan, all things
all
bytes.
things streaming, all things streaming bytes. Cool. All right. Well, what are we going to talk about today?
Well, last week we had a chance to talk about the overall functionality of Bytewax. We talked about this idea of workers and clusters and partitioning, and we introduced the idea of the data flow as a directed graph. We talked about the operators as one of the building blocks, and we talked about the connectors, which enable us to connect to a data source such as Kafka, transform our data through the operators, and then store it in another source through another connector. And today we're going to have a chance to go more in depth on this idea of operators, what they are, and how we can use them.
Awesome.
So could you tell us a little bit about what operators are and, a high level overview of how they work and how Bytewax approaches this idea of the operator?
Sure. Operators are the building blocks to create a data flow. You can think of each operator as a node in a graph. So when you put them all together, you have a series of steps, essentially. And those are your transformation steps. Operators come in different shapes and sizes. What they are um, the control points to the flow of data through the entire data flow graph. And so an operator can have state, so it can collect things, it can reduce things, or it can just modify things one at a time. And so you have some hooks on how data, the control of data flowing through the whole data flow. But that's how I like to describe it.
And you mentioned the word state. What does state mean?
Yeah. So state is a fancy way of saying have an object that's a representation of things that happened or are happening. So if you want to think about that from the perspective of your life, your brain maintains state, so it understands what has happened before and after. So when you sit in a room and you wanted to count the people that came into the room and left, you'd be able to retain that collection of humans in your brain and count them, and that's your state. So that's the kind of replicated model of state in stream processing. And so operators can be stateful or stateless. And so the stateless operators don't have any idea of what happened before or after. They're acting completely independently of what has happened in the past. And the stateful ones, you can program them to keep a record of what has happened in the past, collect things, etc.
Right. So it sounds like with the operators, we can basically transform the data in the stream through this idea of directed graphs where the operator acts as a node in the graph, and the operator will do a specific thing like filtering the data or splitting the data or merging the data or even applying a custom function.
Yeah,
And within the custom function, we can decide whether the operator will act by retaining memory, namely it being stateful, or we can decide, we don't care about it tracking what happened before. In this case, it would be stateless.
exactly.
Right on. So today I wanna share with you some code snippets, and because this idea of stateful is a little bit more complex, I wanted to get started with this idea. Stateful is more complex. I want to start with this idea of stateless operators and what they look like. So I prepared a few code snippets, and I'm gonna go ahead and share those with you in the community center.
Okay, awesome. Excited.
All right. So Last week, we had a chance to talk about how to get started with Bytewax with the operator cheat sheet. So if you want to check out that video to get familiar with how we build the data flows, it's on our YouTube channel. Today, I'm going to go a little bit deeper on this idea of the operators. So we start off by installing Bytewax. And for this specific set of examples, I'm going to be working with a very small data set called smoothie orders, where what I have here is just a simple CSV file that contains the order ID, the time of the order, the name of the order, and then the ingredients that the smoothie requires. So we have a green machine smoothie, a berry blast, tropical twist, and protein powder smoothie.
Yeah.
Okay. Yeah. So as before, we want to get started by using our relevant imports. In this case, we're going to be using the data flow class from the bytewax.dataflow module. We're going to be naming it smoothie orders, and we can the name of this name is not important. I can even just call it init smoothie. And my first operator is the input operator. So what this is doing is it's saying, okay, so I'm going to go ahead and add an input source to my data flow. Now that I've initialized it, it is the first node in the graph. I'm going to give it a name. In this case, the name is orders. I'm going to pass the variable flow. And then in here, I can use a connector. So in this case, I'm using the CSV source connector, which all it's doing is it's just reading this local file called smoothies_orders.csv. If you're reading from Kafka, you can change it into the Kafka connector. And then what I've done here is I've defined a very simple function that takes as input the order, and it's going to return whether the word banana is in the ingredients.
Does that mean you're all out of bananas?
Oh, I hope not.
Well,
I certainly
I'll have
hope
to
not.
take my smoothie order to a competing establishment.
Oh, no, we have bananas. There is no problem with that. And the second operator I want to use is filter. So in this case, filter is going to take as input the operator name. In this case, this is just the name I am giving to this node. I'm going to be giving it the name filter banana. I am passing the previous step. The previous step was orders. And then the third parameter is just the name of the function contains bananas. So when I go ahead and execute this data flow, it's going to filter the results for only those smoothies that contain bananas. In this case, only the green machine and the protein powder have bananas in them. So it ignores the other two. In this case, all I'm doing is I'm using the inspect operator. So this specific data flow contains three operators: input, filter, and inspect. If I wanted to return the results on something like the terminal, I could go ahead and say, I think it's op.output, if I remember correctly.
Mm-hmm.
And I would do return results. And then I would say banana orders. And then I would pass the name of a sink. So there's the std out sink as one of the sinks I can use. Of course, this is just to print or return on the terminal what it is that my data flow is doing. I could replace this for another sink. Like let's say I wanna store my result on a ClickHouse sink. We now have a ClickHouse connector, so we can put our results on ClickHouse, etc. But let's say, okay, so now we have a basic mechanism for using these operators or connecting these operators through the use of the data flow. So one of the things that we notice here is when we filter our results, the end result is this dictionary structure where we have the name of the columns as our keys and then the value as the value. So we're going to have 4 different keys in the dictionary: the order ID, the time, the order requested, and the ingredients. And then as the values, we have each of the corresponding ones. Now, in this case, there's only 2 entries. Oh, yes, as we noticed, there were 2 entries that had bananas in it. So let's take a look now at a different example. So for example 2, what we're going to be focusing on is our main goal is going to change the structure of this data frame, or this data structure in the stream, with the purpose of doing different operations. So one operation I might be interested in might be for me to say, I wanna see how many orders of a specific item were requested, or I want to count the instances that appear. So I'm going to go ahead and first transform the structure of the data stream through the use of the key on operator. So as before, I initialize my data flow. I apply an input operator to read the smoothie orders.csv. And then in here, I'm going to add another step using the key on operator. I'm going to be taking as input the order step, and I'm going to apply a lambda function. So in this case, a lambda function is going to go ahead and take the items under the order requested column. And when we go ahead and inspect this, what we see here is I went from this dictionary structure to this tuple structure. Tuple or tuple?
Yeah, I don't know. It's still up for debate.
All right.
I sometimes call it tuple. I sometimes call it tuple.
I'll go for
Depends on the
tuple.
day.
So now that
I have a question. So why
Yeah.
do we need to key on? Why is this an important thing to do in stream processing?
Yes, so key on is one of those examples or instances where we reshape or restructure the order or the shape of our stream data with the purpose of tracking state. So in this case, for instance, before I had this order ID, I had this dictionary set of I had a data structure that has a dictionary-like shape. But let's say that you wanted to aggregate the data and you wanted to, let's say that you, at this point, it's only taking a look at each entry, but it doesn't really care. Every time it returns a new entry, it doesn't care about the previous one. It just keeps outputting more and more entries. So if I had something like a million rows instead of 4, it's in this specific structure, as far as the data flow goes, it doesn't keep track of what's going on or what the previous entry was. So if I wanted to do something like aggregate or group by, something like the order requested, I would have to do something like key on, such that it's keeping track now of, how many orders that happen to be green machine were ordered on a specific day or time, or on a how many.
So you're saying this is like a preparation step, and my next step now I could count or average.
Yes.
So it's like people from the pandas realm of the world. It's like your group by, or anyone who's used to doing something like group by, key on sort of like that group by, and then you'll have your aggregation statement after.
Yes.
Okay.
And so now we can think of this as being as an ID, but this key or this ID right here can now be kept track. So namely, what I'm trying to say is this is a pre-step for us to apply an example of a stateful operator.
Yeah.
Versus in here, we didn't really care about the state.
In Bytewax, if you try to pass because it's typed, if you try to pass a stream that is not a keyed stream, then the stateful operators will fail.
Exactly. Yes, and that is quite important when it comes to building stateful operations or applying stateful operators. It is a prerequisite to applying a stateful operator to first reshape the structure of the data to this keyed format. In this case, I'm going to make the key the name of the order, where I assume the order names are unique. I only have a unique number of smoothies or smoothie names, and those smoothie names have a specific recipe. So I'm going to go ahead and make this the key. Now, as an example of an application of a stateful operator, I can use the count final, where in this case, the goal is for me to count how many smoothies of a given type were ordered. In this case, I have one of each. So when I go ahead and add this extra step, I will have first, it's going to restructure or reshape the data from dictionary to this tuple, where I have the first element in the tuple being the name of the order. And the second element is just going to be the dictionary containing the remaining or the rest of the data. And this is just inspect keyed. Inspect counted, on the other hand, now tells me, has the key and the number of times that specific item was ordered. In this case, it's only one per each.
Cool.
Right on. Okay, so
what does it mean? What does it mean when it's final? Does that mean this can only be used for a batch purposes, or how do we differentiate? You're using a CSV right now, so is it better to use final when you have a predetermined size and bounds to your data structure? Is that right?
I would say so, yes, because if you had a continuous stream of information, I mean, at this point, I'm running the data flow in this specific moment, but maybe there's more data coming in. So I think I would apply this for a scenario where I have a batch as opposed to a continuous stream of information coming in. Would you agree with this, or would you try something
Yeah,
else?
yeah, 100%.
Now, if I wanted to do it in the other scenario you did, where you have a continuous stream of information, do I have an operator that allows me to count as new instances pop up?
Yeah, I mean, the hard part there, as you alluded to, is we don't know when the data ends. So you have to define some bounds to it.
Mm.
So you have to make the decision on how you're going to bound that count. And so we have window operators to do things like that, or
Mm.
we have a collect operator to collect things over numbers of things. So you have to kind of predetermine how you're going to chop up your stream so that you can do these sort of operations.
Gotcha. Yeah, and we will get a chance to go through windowing in more detail in our next session. Windowing is its own little beast. There's different kinds of windowing and different kinds of ways of designing how you slice the data.
With slice and dicing smoothies.
Slice and dicing smoothies. Let's see. Now let's take a look at an example where we enrich the orders. So in this specific example, I only have these for attributes, the ID, the time, the name of the order, and the ingredients. But I want to enrich my data by adding the price. So in this case, what I'm going to do is I'm going to define a function, and it's going to take as input the smoothie name, in this case, what's under order requested. And given I know that there's only each of the smoothie names uniquely represents a specific recipe, then I can go ahead and make this the key in my dictionary, and I'll just add a price. And I'm just going to go ahead and return the price whenever the smoothie is provided as part of the steps. Now in here, I can define a second function, enrich with price. And in here, we're going to be using this enrich cached operator. Now, I wanna spend a little bit of time on this idea of cached. So Zander, can you tell us a little bit about, what would be the difference between enrich versus enrich cached? So what's special about this cached
Well, I know we
aspect
said
of it?
we weren't going to dip our toes too deep into stateful operators, but here we are. So the enrichment, which is super common pattern like this, and generally you have some static or basically static data set that you need to retrieve data from to enrich your stream. And so we have prices, and we're going to enrich those. The difference here is that we have this cache mechanism, which is basically just an in-memory object that's going to give you a faster retrieval for the same data. So if we're requesting green machine all the time, and maybe our mock pricing service was actually making a request to a database over the network, this cache operator will store it the first time, and then we'll retrieve it from there for the future. And then we don't have to go over the network to wherever our pricing scheme or our pricing service might actually lie.
So it means I don't have to make a query if a query was already made once.
Yeah, you don't have to make that query outside of your application anymore, unless you define some time to live on the cache. So say you want to redo that cache every day. So if a day has passed, and then you can go look it up. There's a lot of flexibility because you can basically set up that pricing service however you want.
Now, one thing that's quite nice about this specific stateful operator is that so in this case, I didn't have a need to change the structure of the data. Why is this the case for this specific stateful operator?
The enrich, well, you're doing the work in those two functions, enrich with price and mock pricing service. But what's passed out of it is the data and the data that you've returned in enrich with price. So you didn't the data structure isn't changed there. Or do you mean as far as stateful?
Yes, like when we did it in this case, for example, before we could count the number of times each of the orders was requested, we had to do this prerequisite step
Yeah.
where we go from this dictionary to this tuple.
Yeah.
But in this case, we didn't need to do this specific step.
Yeah, because it's
Where do we
not
go?
an aggregation. So we
Gotcha.
don't care. And the mock pricing service will live on each worker. So one of the real reasons for keying is that we need to route the right data to the right worker. So because if you have multiple workers and you're counting, you need all the data, you need all the green machines on one worker so that you can ensure you've counted all the green machines. Otherwise, you'll have the incorrect number. In this case, it doesn't matter because you have the mock pricing service on every worker, and that can independently queries. If you had a global cache mechanism that was available between workers, it might be even more efficient, but it's that's something we don't have. So right now it's basically like a hybrid between a stateless and stateful, because you're not you're using these stateful capabilities for the cache, but you're not you don't care what's come before or after.
Gotcha. Gotcha. So what you're saying is I could, if needed, I could increase the complexity in terms of how I keep track of state, depending on the setup I have. If I was making queries to a database to get the price, for example, or if I wanted to set up a limited time for how long you want to cache specific information before it's refreshed, then at this point, setting up something a bit more complex in terms of state would be desirable.
Yeah, that mock pricing service that you created there, you know, that's where you would be doing your lookup and potentially assigning your time to live. So you would like, you know, pass in the current date and the time to live, and then you could
Oh,
refresh the query if it's gone past, something like that. I don't know.
right on. And then as a last example, so just as a last example, we're gonna add the map operator where, let's say my next goal is, once I've enriched the data through a price, I now want to add a second, or a sixth column rather, to add the total price where I include the tax. And in this case, you know, as you noted, Sander, I'm based in Canada. Typically, we add a 15% additional charge for tax. So all I'm doing here is I'm defining a function. It's going to take us input the order, and it's just going to multiply the price that I've just added by 1.15. As before, I had my in this case, I initialized data flow from the beginning. I can then use the map operator to use this function on the enriched orders. And then I now have the final price, or the total price, appended to the stream.
Cool.
Right on. So the last thing to show before, or the last thing to share before we wrap it up is, so in this one, we had a chance to explore some of the out of the box stateful, stateless, and in between operators that you can use to manipulate data. For our next session, we're going to be talking about this idea of windowing and what does it look like when we set up our functions to operate under this stateful assumption. In particular, what kind of assumptions or logic we expect to see for a windowing operator to work. And we'll talk about the different kinds of windowing that exist, when to use each, and then a mini example where we're going to be keeping track of the time that the order was made and make aggregations based off of that. So I think this is it for now, Sander. So I'm excited to do our next session on Bytetalks, on windowing and stateful operators.
We'll see you at the next Byte Talks.
See you.
Bye-bye.